The examples that we solved on this page worked because when we factored the left side, we ended up with a perfect square, a factor multiplied by itself. It doesn't always turn out that way when you're trying to factor something. So what we're going to talk about is a process you can use to transform a quadratic equation so that you do have a perfect square trinomial, so that when you factor it, you do get a square. This is going to be using what we call the completing the square method. So we're going to solve, as we go through the original directions, the equation x squared plus 2x minus 9 is equal to 0. And then we'll move on to some other examples. Step 1 is if there's a number in front of the x squared other than 1, we need that to be a 1x squared for this method to work. So if that had been, for example, a 3x squared, we would have divided everything by 3. We'll take a look at an example like that in a later video. In this case, we don't have to worry about that. The second step is where we're going to be starting this example. We want all the variable terms on one side of the equation and all the number terms on the other side. So here we're going to leave the x squared and the plus 2x where they are, but we want the constant term to be on the other side, so we're going to add 9 to both sides. This leaves us on the left side with x squared plus 2x, and I'm going to leave a blank space there because I know I'm going to add something in there in a moment. And then on the right side we have 9, and again I'm going to put plus a blank space just because I know I'm going to be adding something there in just a moment. Now is the key step of what's called completing the square. We're looking at this step number 3 here. Look at the number that is the coefficient of x on the left side. Here we have 2x. We want to take half of that coefficient. In this case, half of a positive 2 is a positive 1. Then we want to take whatever that number is and square it. In this case, 1 times 1 gives us 1. And we're going to add that result on the end of our left side. To keep the equation balanced, since we added 1 on the left side, we also add 1 on the right side. So now what we have at this point is the equation x squared plus 2x plus 1 equals 9 plus 1. So far, it may look like we've made this equation more complicated than the one we had to begin with, but now take a look at what happens if you factor the left side. To multiply to be 1, but add up to 2, you would need 1 times 1. In other words, factoring it, we would get x plus 1 times x plus 1, or x plus 1 squared. A shortcut that's going to make solving these problems faster, if you do this step 3 correctly, the half and squaring step, whatever we've written right here tells us what goes in the parentheses with x. Half of that coefficient of x was a plus 1, so we have x plus 1 squared. On the right side of our equation, 9 plus 1, we have 10. Now we can use the square root property to finish. We take the square root of both sides. When we do that, we put a plus or minus in front of the right side. The square root of x plus 1 squared is just x plus 1. We can't simplify the square root of 10, so we leave it as the square root of 10. To get the x by itself, we subtract 1 from both sides. Those are not like terms on the right side, so we don't really need to split it up. And we would have x equals negative 1 plus or minus the square root of 10. If you do want your answers written individually, it would be negative 1 minus the square root of 10 and negative 1 plus the square root of 10. Let's take a look at another example. Here we have x squared plus 8x is equal to 1. Well, we already have a 1x squared, so we don't need to worry about step 1 from our list up above. We already have the variables on one side and the number on the other, so we don't have to do anything for step number 2 from our list above. Let's do that key third step. Just to make it easier visually, I'm going to go ahead and rewrite this with the plus a blank space at the end of each side. X squared plus 8x plus a blank space equals 1 plus a blank space. Now the key step is we have a plus 8x, half of plus 8 is plus 4. And then when we take the plus 4 and square it, we get 16. Since we add 16 on the left side to keep it balanced, we also add 16 on the right side. And then using that trick we talked about, because we have a plus 4 here, the left side, when we factor it, is going to be x plus 4 squared. On the right side, 1 plus 16 gives us 17. Now we take the square root of both sides. The square root of x plus 4 squared, we have x plus 4. On the right side, don't forget, we have the plus or minus square root of 17. To get x by itself, we would subtract 4 from both sides, leaving us with x equals negative 4 plus or minus the square root of 17. Or if you do want the answers individually, it would be negative 4 minus the square root of 17 and negative 4 plus the square root of 17. If you'd like to try the next problem on your own, solving using this process that we call completing the square, pause the video now and resume when you're ready to see the solution. We have 1m squared at the beginning, so we don't need to worry about step 1, the dividing step. The next step that's important to remember is, unlike solving by factoring, with completing the square, you want to just have the variable terms on one side, the constant term on the other. So to get that here, we would add 7 to both sides, leaving us with m squared minus 6m plus, and we'll leave a blank space, equals 7 plus a blank space. To figure out what's going in those blank spaces on both sides, we look at the coefficient of m. Here we have a minus 6. Half of a minus 6 is a minus 3. Minus 3 squared is a plus 9. Notice when you square something, even if it was negative, when you square it, it's going to become positive. Since we add 9 on the left side to keep it balanced, we'll also add 9 on the right side. Now, because we have a minus 3 in that middle step, when we factor, we would have m minus 3 squared equals, and on the right side, 7 plus 9 is 16. Now we can finish using the square root property. We'll stick a plus or minus in front of the right side. The square and square root cancel out, leaving us with m minus 3 on the left. The square root of 16 is 4. Now here, because 3 and 4 are like terms, it's good to go ahead and split it into 2 equations. M minus 3 equals 4, and m minus 3 equals negative 4. And to finish, when we add 3 to both sides of the first one, we have m equals 7. When we add 3 to both sides of the second one, we have m equals negative 1.